Hello, my awesome audience. You're welcome back to my channel. My name is Helen, and in today's tutorial, I'm going to be showing you step by step on how to create and run a Kubernetes cluster on Amazon EKS. This Kubernetes service is actually a managed Kubernetes service to run Kubernetes in AWS cloud and also on-premise data center. Amazon EKS manages the control plane operations, scaling, high availability, security patches, and integration with AWS services, allowing users to focus on deploying and managing the application workload on Worker nodes. So you basically need to now take care of your workload. You don't bother about scaling or high availability, security patches, integration with any other AWS services, because Amazon EKS does that for you. So any user using EKS service will basically focus on deploying the application workload on Worker nodes. Okay. Amazon EKS offers built-in integration with AWS services such as EC2, VPC, IAM, EBS, and more. Also reduces costs with efficient compute resource provisioning and automatic Kubernetes application scaling. So you're sure that the cost will be reduced for you, right? Instead of running some sort of on-prem setup and all that, EKS actually reduces cost for you and ensures that there is automatic Kubernetes scaling for you in place. Cluster will be deploying today will be running in private subnet. Okay, so deploying your Amazon EKS cluster in private subnet will basically help to provide enhanced security, reduce attack surface. It will help for control network. It will help to control network traffic. It will help in compliance adherence and also improve isolation for your sensitive workloads. Subnet, it will basically have two private subnet and two public subnet. First are deployed in private subnets will actually help you to align with best practices for safeguarding your Kubernetes infrastructure and ensuring the privacy of your applications and data. And let's start the deployment right away. But before we go ahead, please subscribe to my channel if you are yet to do so. Also click on notification bell, that way you get notified each time I publish a new video. And I'm signing as an IAM user. Okay, please ensure you're signing in as an IAM user, and you as an IAM user, you should ensure that you have the permission. Okay, you have the permission to run your EKS cluster in AWS. All right, so that is it. If you log in as a root user, you might actually experience some issue later in the class, so you don't want to run into an issue. All right, so first of all, let's create a custom VPC. The custom VPC will contain two public subnet and two private subnet. So we'll have two availability zones. All right, we have private and public subnet in one availability zone, and then the other public and private subnet in the other availability zone. I'm actually using North Virginia region. You're free to use any region that that you want to run your cluster. So now I can see VPC here, but in case yours is not displaying, just type VPC, then click on that. Right, so this is my VPC dashboard. I'll go ahead and click on create VPC. And when you're about to create your VPC, you'll see VPC only and then VPC and more. So if you want to create VPC and then VPC component like internet gateway, NAT gateway, route table, and all that, you need to select this VPC and more, and that is what we are going with. So here, name tag auto generation. I would like to name this EKS. Okay, and the IPv4 CIDR block is this, and that is fine. The tenancy is default, and that is okay. Number of availability zone is 2, so that is fine. Number of public subnet is 2. Number of private subnet we'll be using is 2 as well. So scrolling down, NAT gateway, want us to make use of just one NAT gateway, right? And VPC endpoint, I don't really want to use VPC endpoint because this is not really production EKS cluster, but in case yours is production, you may want to go with this. Is actually very important. DNS option, DNS hostname and DNS resolution is enabled already. And coming to this preview section over here, okay, so I'll be leaving a link in the description below because I've actually published a video where I created VPC and the component, and that is actually very detailed. So you may want to learn that in order to see how you can actually deploy all this yourself, the VPC and the component. I actually explained that in detail. All right, so let's go ahead. So we have in this subnet over here, we have public subnet in US is 1A, and we have public subnet 2 in US is 1B. Here we have private subnet, private 1 in US is 1A, and we have another subnet called private 2 in US is 1B, and that is actually fine. Coming to this side, route table, we have one public route table and we have private two private route table in different availability zones. Coming to this side, we have internet gateway. So we have one internet gateway and one NAT gateway. Internet gateway is for the public subnet, while NAT gateway is for your workload that will be in private subnet. And this is looking fine, so we can actually go ahead, and in case you want to customize this name over here, maybe customize all this name, you can actually uncheck this auto generate and it can help you to customize this name. All right, so let me go ahead and create this VPC. So I'll click on create. Okay, this can actually take up to 2 to 3 minutes to create because NAT gateway is not really that fast in provisioning. But I'm gonna pause this video and I'll come back once the creation is completed. Okay, so after about 2 minutes, I could see that the VPC and the components are actually completed. So I'll click on view VPC and the VPC, right? So this is the VPC I created, so that can help to filter out the subnets that this VPC has provisioned for us. So over to route table, let's check the internet gateway, and we have internet gateway over here. And now let's confirm if it provisioned elastic IP for us. You can see one elastic IP. And let's check the NAT gateway. This is it here. So one NAT gateway was provisioned for us. Perfect, great. So let's go over to EKS, elastic container size. So once you type EKS in the search bar, you should see elastic Kubernetes service rather. So I'll click on that. Great, so you can see add cluster here. So just click on this drop down and you see create. Over here, let's name our cluster. So basically we are trying to provision the control plane node. All right, so yeah, it is after this control plane node we'll now start talking about the worker node. All right, so let me name this EKS cluster, and the Kubernetes version we'll be making use of is 1.27. that is actually the latest. Cluster service role, so we need to select an IAM role in order to allow Kubernetes control plane to manage AWS resources on our behalf. So because we really need that role, we have to go and create it before we continue. So I'm going to another tab. I actually have another tab open, but you can actually duplicate the tab, okay, so it doesn't disrupt what you're trying to create. So let me go to IAM. Okay, so here you can see roles by the left navigation pane. Click on roles and click on create role. Right, so under trusted entity type, AWS service is selected already. So under use case, click on this drop down and type EKS. Okay, I'll click on this EKS, and then it will show us some EKS options. So I'll select EKS cluster, then I'll click next. The permission policy will be attaching. Okay, it's already attached. Perfect. Amazon EKS cluster policy is the name. So we go ahead, I'll click next, and I would like to name this row. Okay, control plane, and that's fine. So I'll just go ahead and click on create row. Great, view row. So you can see under permission we have this policy. Great. So let's go back to creating our control plane node, our cluster. So here just click on this to refresh and the row should appear. You can see the role is showing already. So under secret encryption, please, if this is production cluster you're trying to spin up, ensure you turn this on, though it depends on your requirement, but this is actually for security. So you can turn on the envelope encryption of your Kubernetes secret using KMS. I don't want to use that, so let's go ahead, click next. So under VPC, I'll select the custom VPC that we created. Under subnet, I'd like to deploy this cluster in two private subnet. Okay, and I want to use private subnet 1 and private subnet 2, which are running in different availability zones. So let me just get rid of the public subnets that are being displayed here. So I have private 1 and private 2, and that is fine. So security group, I don't want to choose any security group because automatically EKS will launch or create a new security group for this control plane node. All right, so scrolling down, choose cluster IP address. IPv4 is fine, and you can toggle this on if you want to configure Kubernetes service IP address range, but I don't really need this. So this will be running, this is actually a private cluster, so select private, so you can have a private cluster endpoint access. So click next, and under control plane login, agnostic. If this is production cluster, I believe you definitely need to have your logs. All right, so you can go ahead and select the one that you want. If you want all of them, that is actually fine, but we don't need it, so I'll just click on next. Okay, and now this is Amazon EKS add-ons. So we have code DNS. This can enable service discovery within your cluster. This Amazon VPC CNI, right, will enable pod networking within your cluster, which is very important. Kubeproxy enable service networking within your cluster. So these three are actually selected already, and that is fine. If this is production cluster you want to provision, you may need this guard duty EKS runtime monitoring. It's basically for security. So I don't want to select that. Let's click on next, and if you want, you can actually go ahead to configure these three add-ons. Okay, but I don't want to. I'm actually good with what we have here, so I'll click next, and here you can review and create. So but I'm good, so I'll click on create. Alright, so creating this EKS cluster actually takes some time, so about 10 minutes or thereabout. But before we I don't want us to just keep waiting for this. We can actually go ahead to creating our node group. But before that, let's create a security group and keeper, which we can use to provision the worker node, okay, which is node group, because over here in compute, even after this cluster provision is ready, we won't have any nodes here. So we basically need to add our worker nodes, okay, by creating a node group. But before then, let's go and create a security group. So I'm gonna go to my other tab. Let me go to EC2. I'll click on EC2. And over here I'll scroll down to where we have security group and click on that, and then I'll click on create security group. Like to name it, okay, let me name it node group SG, and I'll use same name as the description, and I'll select, just remove the one we have here, select the custom VPC you've created, and over here I'd like to add a rule. I can actually add, even though I might not really need this, but let me add SSH, and I'll use anywhere IPv4, but remember, if this is production, you don't want to use anywhere IPv4. Okay, you can customize it or use my IP. Okay, so let's create this security group. And the next thing we have to create is key pair. So this is key pair under network and security. I'll click on key pair. I believe I have key pairs already, so I have key pairs created. Okay, so I'll be using any of these, but if you don't have a key pair, just click on create key pair, enter the name of key, enter whatever name you want to give to your key pair. So under private key file format, use .pem if you're using Mac or Windows terminal, but if you're using SSH client like PuTTY, you definitely need to use this .ppk. Okay, so go ahead and click on create key pair. All right, so let me cancel this. Alright, so let's go back to cluster and see how it's going. So this can take some time. I'm going to be pausing this video and I'll come back once it is completed. Alright, so I could see that the status is now showing active. So our cluster is ready. Okay, I'll expand this cluster info and you can see the status is active. Resource collection. So I don't really want, let me just delete this. It doesn't really matter, so I'll just get rid of it. Alright, awesome. So now that this is ready, the control plane is ready, we can actually go ahead to creating the worker node. But before that, let me just take you around. Under resources, you can see you know, some Kubernetes resources over here like ports, replica set, deployment. Okay, so resource here. Okay, so but if I go to if I expand this cluster and click on nodes, you will also see that we don't have any. So basically we have to create the worker nodes. All right, create the resources we want to see. So under compute here, we don't have any worker node, that is why it is empty. But for us to create a node or worker nodes, we need to create a node group. Okay, so coming to networking, we have VPC subnet, cluster security group, API server endpoint, and all these networking solutions. Under add-ons, you get to see the 3 add-ons that we selected while we were configuring the control plane. And so that is it. You can just go ahead to see. Under authentication, we don't really have anything. Under login, we didn't select login system. All right, so let's go ahead to create our node group. So I'll go back to compute and I'll scroll down and click on add a node group. Okay, what is this node group? What is it all about? So a node group is a group of EC2 instances that supply compute capacity to your Amazon EKS cluster. You can add multiple node groups to your cluster. So once we provision this node group, it can help to spin up our worker nodes. All right, so this is where we'll be defining the number of worker nodes we want and all that. Node group, or I can say my node group. Okay, and under node IAM role, we'll also create an IAM role for this node group. Okay, so to create IAM role, we need to go to IAM. All right, so let's go over to IAM to create a role. I have another tab open, so I'll open that and type IAM here, and I'll click on IAM. Okay, under left navigation pane, I'll click on roles, then I'll click on create role. Okay, I'll just scroll down and under use case, I'll select the EC2 and click next. Okay, so under permission policies, I'll type worker. press enter. So I want to select Amazon EKS worker node policy. Just check the box, and we also have two other policies will be attaching to this row. So let me just get rid of this worker here, and then I'll type container, press enter. So I want to attach Amazon EC2 container registry read only. This will actually enable the worker nodes to have permission to pull images from Amazon ECR. Okay, so that is it for this permission. And let me get rid of this container so that I can type the other one, which is Amazon CNI. Okay, so we have CNI, press enter, and this is Amazon EKS CNI policy. This is basically for CNI stands for Container Networking Interface. It's for networking solution. Okay, please ensure you attach this policy so you don't have any networking issue. All right, so that is it. You can see 3 selected. Ensure that 3 is showing here. So let's go ahead. I'll click next, and here I would like to name it node group row. Okay, and then I will scroll down, click on create row. Right, so view row, it has been created, and this is the row and the 3 permissions we attach. So let's go back to the other tab to go ahead with our node group creation. I'll refresh this so that the row can appear here. This is node group row, and that is fine. So let's go ahead. I'm not using any of this, so that is fine. I'll scroll down and click on next. So the node group compute configuration, this is where we configure the compute configuration basically. So AMI type you like to use, so this is where you select the AMI type. Amazon Linux 2 is fine. Capacity type is we'll be using on demand. Okay, instance type I would like to use, let me get rid of this T3 medium, so let's use T2 medium. Okay, click out. Alright, so the disk size 20 is fine. So coming to this node group scaling configuration, what is the desired number of worker nodes you like to start with? I'd like to start with 2. So the desired minimum size, maximum, I'll leave them as 2 to 2. Okay, maximum unavailable. So what this place actually, what this place means is the number of unavailable nodes you like to have when there is node group version update. Okay, so I would like to have 1 unavailable node. I don't want to, you can actually select the number or you use percentage. I don't want to use the number as 1, so 1 is fine. Okay, so I'll click next, and here you have to select the subnet. So obviously we'll be running these worker nodes or our worker or our node group in private subnet. Okay, so the 2 private subnets we have has been selected, and that is fine, so I'll leave it the way it is. So I'll toggle on this configure remote access to node, because we definitely need to have a remote access to our nodes. Okay, so I'll just toggle it on, and then I'll click enable. Please ensure you enable this so you don't get access denied. And this is where you now select the key pair you've created. So I'll select this, that is what I want to use, and allow remote access from security groups. So you need to select the security group that you've created as well. So this is not really showing. Okay, so this is the node group security group, and I'll select it, and I'll click on next. And over here in this page is to review and create. So please review what you've configured to ensure that you're not making any mistakes. So my own looks good. I'll click on create. You can see the status says creating, and that is fine. It will be provisioning 2 EC2 instances for us, all right, and that will be our worker nodes. Let me actually go to my other tab and locate EC2. Let's check if it is actually provisioning the worker nodes for us. And great, you can see the two EC2 instances being launched for us. These are the worker node, and you can see they are in two different availability zones. Okay, one is running already, and we have to wait for this. Two are running, so let's get back to our node group and see what is happening. It's still showing creating. Let me try to refresh it. Okay, so let's give it a moment. Awesome, is now showing active in our status. Okay, let me close out this. All right, so if I go to node tab and click on it, you can see we have two nodes here, and you can actually select any of them if you want to see the details. Go over to the next stuff we have. So the next step now is to create a bastion host, because obviously we have our control plane and our worker nodes. Okay, we have our control plane and two worker nodes. So in order to be able to have access to this cluster we've provisioned, we'll go through bastion host. Okay, so using a bastion host to connect to our EKS cluster is actually a security best practice for managing resources in private subnet. Okay, it will help us to maintain control, restrict access, and ensure the security and integrity of our cluster infrastructure and data. So let me go over to EC2, launch an instance, because a bastion host is actually a server that can help you to connect securely to say another server. Okay, so let's click on launch instances. Let's name it bastion host, and scrolling down, we'll be using Amazon Linux 2023, and it is selected already. Instance type will be using a C2 micro. That is fine. I can create a new key pair or use the same one that I use for my node group. That is fine. You can go ahead and create a new key pair if you want. So under network settings, I'll click on edit, and I would like to select the custom VPC we created. Under subnet, I'll be provisioning this in public US East 1A. Okay, so ensure you select a public subnet for this bastion host, because obviously you need to launch that in a public subnet. So all right, so under auto assign public IP address, I need to enable it, and we'll be creating a security group for this bastion host. So copy that and paste it here, and we have a default SSH rule, and that is fine. So since the inbound rule for SSH is defined here, that is fine. But if this is production, you may want to restrict it to a custom IP address or your IP, okay, for security. But I don't have anything to worry about, so I'll leave it the same way it is. The storage is fine. So let's go ahead and launch this bastion host now, and click on view all instances. Please, if you're enjoying this video so far, please be kind to give me a thumbs up, right? Comment if you have any question, or you may just comment to share your feedback about this video. Also subscribe if you're yet to do so, and click on that notification bell so you get notifications anytime I publish a new video, because I've got a lot to share with you guys. All right, so here the bastion host is now running, but before we go ahead, I would like to name the worker nodes. So I can name it worker 1, save, and I'll click on this pen icon to give this one worker 2 and then save. All right, so what is the next step in this process? The next step is to connect to our EKS cluster, but we'll make use of this bastion host that we just launched. So I'll select this bastion host, and I'll scroll down. Let me expand this. Okay, so this is the public IP address, and I'll be using git bash. So it doesn't matter the computer you're using, whether Mac, you can use your terminal or you can use a search client. Okay, so the key pair that I use in provisioning these bastion holes has been added to the path that this terminal opens to. So ensure that in your file manager you go to this path, and then wherever the key pair was downloaded to in your computer, ensure that you copy it and paste it in this path so you don't have issue in connecting. So right now let me paste the public IP address. Okay, so are you sure you want to continue connecting? Yes. So now that we've connected to our Bastion host, the next step is to configure our, our terminal with AWS credentials. Okay, so we need to run AWS configure and configure our credentials, all right, in order for it to be authenticated. In order for it to have access to our accounts, we need to come to IAM. So let me go to IAM users. So I'll show you the existing credential in this account. I have a credentials already that I can actually use. Okay, so I have access key and secret access key ID, and it is active. And in case you don't know how to create this, I'll be leaving a link in the description below. In case you don't have credentials already, I'll be leaving a link that can help you to create your IAM credentials. All right. Okay, so to configure this, all you have to do is to run AWS configure, press enter, and then you paste the access key ID. Okay, and it will request for AWS secret access key. I'll copy this and paste it. Okay, default region name, I'm using US is to 1. Press enter. Default output format, let's type this one and press enter, and that is it. Okay, so in order to check whether this has been configured correctly, the command to run that is AWS stg or sts, sorry, and then you type get caller identity, press enter, and you can see the user ID, the account, and the ARN. Okay, and this makes sense. All right, so let's go over to the next step we have in this process. And what is the next step? The next step is to install kubectl or kubectl, depending on what you call it. All right, so let's configure our kubectl. So I actually have some resources, the URLs we'll be using. Okay, so to configure the kubectl, I'll go to this page. I'm gonna be dropping this link in the description below. All right, so paste this, and it will take me to a page where we'll get to install the kubectl 2, so that we can have it can make call to our API resources, so we can run our normal Kubernetes commands. Okay, so so over here we are using Linux, right, and these are the commands. So I will, because we are using AMD 64, we are going with this first command, so I will just be following the commands we have here. So I've copied the first one, and I'm gonna paste it here and press enter. Awesome. Okay, so let me go and copy the next one. So remember, we are running Kubernetes 1.27 version. All right, so it depends on the version you're running, that will determine the command you use for this. So I just copied the one for 1.27, this first one, and I will scroll down to where we have the next step. This one is optional, so you can verify the downloaded binary, because we just downloaded the binary. So let me copy this one so we can Okay, this looks good, and we go to the next step. So we can check the checksum for the downloaded binary. Okay, so let me copy this and run it. And kubectl is okay. All right, so let me scroll down and also copy this open SSL SHA1, and let's run it. But before I go ahead, let me clear this screen. I'll paste this. Okay, and this looks good. So going back, let's apply execute permission to the binary, and that is by copying this, paste it over here and enter. Okay, if I run ls, you can see the kubectl is actually here, so we've just given it permission, and now we can now copy the binary to a folder in our path. So all I need to do is just to copy this and run it. Awesome. And then so we need to now add the home/bin path to our shell initialization file, so that it is configured when you open a shell. I'll just copy this and run it. Okay, fine. And then I will copy the kubectl version that's short, just for us to verify. Okay, client version 1.27.4. okay, so we actually installed this successfully, and that is the end of it. All right, so now that kubectl has been installed, we'll go over to the next step of the process, and the next step is to create kubeconfig file for our cluster. And to create the kubeconfig file, I will be opening up this resource using this URL. So I'm gonna paste it here. So in this page, you can see creating or updating a kubeconfig file for an Amazon EKS cluster. If I scroll down, we'll be creating it automatically. Okay, so scrolling down here, you see to create your kubeconfig file with AWS CLI. By the way, our Amazon Linux has AWS CLI already. Okay, if you type AWS CLI and press enter, you can see the CLI option, AWS CLI options here. So we actually have that in Amazon Linux, so that is fine. So to create our kubeconfig file with AWS CLI, I'll just copy this and I'll go to my cluster. I'll clear the screen. Sorry, I'll go to my terminal rather, and I'll paste this, and then I'll like to replace this region code with the actual region that our cluster runs. So our cluster is running in US East 1, and then the name of our cluster is EKS cluster. Okay, and I'll press enter. Added new context, and yeah, so this is great. So let's see the next command. If I scroll down, test our configuration. Let's test our configuration. So I'll just paste this. Okay, it is not actually working. kubectl cluster info, terminate it, but then this one will work. Okay, kubectl config view, so we view our config, the config file. Okay, so this works, and this will show you your cluster, and This is the context. This is the context that was just added for us, and this is the user, this is the name, current context is this. Okay, so you basically see the information about your cluster over here. In order for us to run other kubectl commands in this cluster, we need to add a connection from this bastion host to our cluster so that they can communicate. And okay, going to this tab for EKS cluster, let me click on clusters, click on cluster, and I would like to go to, okay, let me go to networking, and under this cluster security group, okay, I'll click on it. So we need to have 443 enabled, HTTPS traffic enabled. So I'll go to inbound rule. After clicking on inbound rule tab, click on edit inbound. Alright, so I'll be clicking on add rule. I'll be selecting HTTPS. Alright, because for kubectl to connect with the API server, we need to have this port open, and it has to be the bastion host, so we want to restrict it to the bastion host. Alright, so I'm going to be selecting the bastion host security group here, and that will be that. So click on save rules. Kubectl will actually work this time, so let me clear this, and then let me run kubectl cluster info, and you can see it is working. So this is the Kubernetes control plane and the URL where it is running. The code DNS is running at this URL, and that is fine. Let's check the other kubectl get SVC. You can see we have the default cluster service here running. All right, and let's actually check the nodes. Kubectl get nodes, and you can see we have 2 nodes here running, okay, and they are ready. Now the next step is to configure our EC2 instances to make use of IAM role instead of IAM user, because remember the credential we made use of is IAM user credential, but the best practice is actually to have our servers create a role which we can attach to our EC2 instance, so it can make use of IAM role instead of IAM credentials. Okay, so I'll open IAM tab, and this is roles here, so I'll click on roles, and I'll click on create role, select EC2, click next, and over here in permission policies, we don't really need to attach a policy. Yeah, you don't really need to attach a policy to this, because currently no policy is required for accessing EKS cluster. No policy is actually required. We just want to kind of fulfill all righteousness, right? So we just leave it empty. All right, so click on next, and so I'll over here I'll type bastion role for EKS. Okay, and scrolling down, I'll click on create role. All right, perfect. Now once this role has been created, we'll go over to our bastion host to attach the role. Awesome, the role has actually created without permission. That is fine. So let me go over to, okay, can actually search for EC2 here, and I'll select EC2. So click on instances running, and let me expand this. I'll select the bastion host, and under this action, just click on actions and click on security, modify IAM role. So here you then select the role you just created, right? So I name my bastion row for EKS. This is it here, and I'll update IAM row. Okay, so this makes sense. Coming back to this place, so I want to show you the credential will still be showing anyway. AWS configure list. The IAM credential is actually still here. So what we basically want to do is to get rid of we basically want to make use of IAM role, which we just attach to the Bastion host. Okay, we don't want to make use of this credential because the best practice is to make use of IAM role basically. All right. If I also run this command AWS sts get caller identity, it is still making use of the credential. Okay, we'll take care of this. We'll actually take care of this. Right now I want to describe my config map. Okay, so we have a config map called AWS auth. So let me take you to that, and I'll show you how we can actually make changes to that config map. So let me go to, let me configure my alias so that I don't get to run kubectl all the time. So alias k equals to kubectl. All right, so kubectl describe. Before we describe it, let's get the config map. So I want to show you the config map I'm talking about. Get config map, which is running in kube system namespace. Okay, so this is the AWS auth config map. So here I would like us to describe it. So describe it. All right, I'll type kubectl describe. So the name of this config map is AWS auth. Okay, so this is it. This is what we have in our AWS auth config map. Okay, so basically I want us to make some modification to this config map, right? So we want to replace it with our own information, the row information, the IAM row information basically. So before we go ahead, let me clear this. Let's take a backup. All right, it is always good to have a backup so that in case if you mess anything up, you can still have it intact. Called config map dot or let me say config map backup dot yaml. Okay, backup is this, and press enter. If I run ls command, you can see the config, the backup here. So this is now having the config map configuration. All right, now we can go ahead. I would like to take you to this page, update config file, paste the URL. Okay, in the left navigation pane, click on enabling IAM principal access. Once you click on that, scroll down. Scroll down to where you see edit config map manually. Okay, click on this tab, and you can see IAM best practices recommend that you grant permissions to roles instead of users. If I scroll down, over here you can see API version v1. I'm interested in copying what we have over here, so I'll copy these groups, EKS console dashboard full. Just copy whatever you have here, right? In this cluster right now, I'll use this command to access or to edit the config map. All right, so that is kubectl edit config map, which is running in kube system namespace. Okay, so the name of the config map is AWS auth. Awesome. So in this page, I would like to come down over here. press enter and take my cursor to align with this dash here and paste what I've copied. Awesome. All right, so we need to copy the row ARN, the row we created, the bastion row we created. We need to copy the ARN and replace it with what we have here, and also the username. So let's go to the row for our bastion. Or click on rows. Okay, let's locate the bastion row. This is it here. Click on it to open, and you should see the ARN. Just copy the ARN, go back to the cluster. Okay, so I'll be deleting. I'm gonna paste this. Okay, awesome. And this username, so be deleting the username we have here. Hi. And now the bastion I am row name. What is the row name? Is actually this this row name is the username. So just copy this row name and I'll paste this. And this works. So ensure that where you're making changes is the one you pasted here. Don't touch the existing configuration, okay? And over here for this first one, I'll need to delete this, whatever we have here. So what I need to have here is system and then column masters. Okay, so this is all I need to have here, and it looks good. So okay, this looks good. So let's go ahead and save this. Okay, it seems something is wrong. Let me go back. Shouldn't have added a space between system and master, so let me correct that. Really get saved. So the changes did not get saved, but it created a copy of the changes we've made already, so I don't want to start afresh. Let me quit the terminal so you can see you can run kubectl replace. So this is where the changes were saved. So let me go into this file. I'll just run vim and paste this and go into this file. Okay, so okay, so this looks good. I will save it. So we can then use replace command. Sorry, I need to type kubectl replace -- force -f. Okay, we can see config map AWS of the replace. All right, so let's get this and let's try to access that. Sorry. You can see, all right, 25 seconds ago, so it actually recreated it. All right, that makes sense. So what is the next step right now? Let's run AWS configure and check if the row that we just updated is now displaying. Configure list. The credential is still displaying even though we've added the IAM role information in our config map. Okay, that is fine. So to resolve this, let's go ahead and remove this AWS config file. So there is a file called AWS/config. So I would like us to get rid of that. Okay, sorry, we need to have / here and press enter. Right, and the next one is Charles. Awesome. So now let's run AWS configure again and see what has happened. Awesome. As you can see, it is now making use of IAM role. It is making use of our IAM role. You can see when we ran it here, it was making use of the credential, but now it has been replaced with the IAM role just because we got rid of this. All right. So if we also run AWS STS, see, you can see ARN, it is now making use of the ARN for the Bastion host, Bastion row for our EKS. All right. Okay, so this works, and right now we can actually go ahead to start deploying whatever we want. Create your pods. If I run kubectl get pods dash a, you can see we have our kube proxy, code DNS, and the AWS node. So everything is actually working perfectly, and you can go ahead to create. Let's quickly create a pod. Image equals to nginx, just to show you that our cluster is running perfectly. Pod has been created, kubectl get pod, and you see that this pod has been created and it is running. Okay, so thank you so much, and right now you can actually go ahead to enjoy your cluster on EKS. Thank you so much for sticking to the end of this video. Please, if you enjoyed this video, be kind enough to just give me a thumbs up, comment, share your feedback, and as well subscribe to this channel if you are yet to do so. Click on notification bell so you get notified, because I have a lot of videos to share. You will get to do a lot of hands-on, a lot of projects, a lot of tutorials. So please subscribe and turn on notification. Also do be kind enough to share this video with your friends. And in case you want to have an automated system for deploying this cluster, I will consider this. If you want me to create an EKS cluster with Terraform or EKS CTL, please comment in the comment section. All right, let me know that you actually need a way to automate this cluster, and I'll go ahead to create the video, because I really want the best for you. But this video basically will help beginners that really want to know how this whole configuration is put together in order to create a cluster. Thank you so much. I will see you in my next video. Bye.